So here we go with Chapter 5, number 21. It reads, Zach, whose mass is 80 kilograms, is in an elevator descending at 10 meters per second. The elevator takes 3 seconds to brake to a stop at the first floor. A. What is Zach's apparent weight before the elevator starts braking? B. What is Zach's apparent weight while the elevator is braking? Alright, so we're going to start with what we know, and we know that Zach's mass is going to be 80 kilograms, and we can draw a free body diagram of him. We've got his weight going down, we have the normal force, so the apparent weight that's going up. So if we look at part A, right, they say that he's moving at constant velocity, right, that 10 meters per second as he goes down. So because he's moving at constant velocity, that means that his acceleration is going to be equal to 0. And that'll help us solve some problems. So we then have that the sum of the forces in the y is equal to ma sub y, where a sub y is equal to 0. And we have his apparent weight minus his weight is equal to 0, or f sub a is going to be equal to mg, or f sub a is equal to 80 times 10, which is then 800 newtons. Part B asks us, what is his apparent weight during that braking period? So if we're going to find out what his apparent weight is during the braking period, we need to know what the acceleration is. And he's moving from an initial speed of 10 meters per second to a final speed of 0 when he comes to rest at the bottom of the bottom floor, and it's going to take him 3 seconds to slow down. That's all we need to find the acceleration. We have a equals v sub f minus v sub I over t, where we get 0 minus 10 divided by 3, or our acceleration in that y direction is going to be 3.33 meters per second squared. We can take that information now and find out what his apparent weight is. So we get the sum of the forces in the y is equal to ma sub y, or that apparent weight minus his weight is equal to ma sub y. Or f sub a is going to be equal to 80 times 3.33 plus 80 times 10. And when we put that all together, we find that he feels like he weighs 1,066 newtons, because that extra acceleration is now working against him to stop him, so he's going to feel heavier than he actually weighs. So that is Chapter 5, number 21.